students, we're going to start working out on Chapter 8. It turns out that Chapter 8 has specific types of reactions. So we said that for this section, for this very next exam, we were going to be looking at different kinds of reactions, specifically substitution reactions, elimination reactions, addition reactions, and radical reactions. The substitution reactions we have looked at length, and basically they entail a nucleophile exchanging itself for a leaving group. So when a nucleophile replaces a leaving group, that is known as a substitution reaction. If, on the other hand, the nucleophile acts like a base and instead of attacking the alpha site, attacks the beta site, that's when we have an elimination occur, because both a beta hydrogen and the leaving group are removed from the equation to create a double bond. And those kind of reactions were known as elimination reactions. The third kind of reaction that we're going to be talking about in this section are addition reactions. Addition reactions is, as the name implies, when you add something to a compound. But you can't just add something to a compound if there's nothing there but carbons and hydrogens. You need to have something or a place where you can add to. That's where a double bond or a triple bond comes in, because you can add things to either side of the triple bond. There are many different things that we're going to be adding in this section, and each one of them has a specific name based upon what it is that is being added. And you will find that these names are pretty much common sense. So let's see if we can go through it. If we add two hydrogens across that double bond, meaning if the double bond goes away and then we add a hydrogen to this position and add a hydrogen to this position, that's adding two hydrogens, one to each one of the different carbons. When we add hydrogens, we refer to this reaction as a hydrogenation. So pretty common sense, hydro for hydrogen, genation for the creation of a reaction in which hydrogens are being added to it. For the second type of reaction, we have a reaction in which you're going to add a hydrogen and a bromine. Well, it could be bromine, it could be chlorine, it could be something else. So in this case, we're going to call it a hydro. And then because this can be ubiquitous, it could be chlorine, it could be iodide, it's just a halogen. So a hydrohalogenation is the creation or the addition of a hydrogen and a halogen across the double bond. So we're going to be looking at hydrohalogenation reactions as well. The third type of reaction that we're going to be looking at is when we have the double bond, and instead of the double bond, we're adding a OH and a hydrogen. Because an OH and a hydrogen together equals HOH, that's water, these kind of reactions are known as hydration. So hydration reactions, just like when you drink water after you've been playing sports, you're hydrating yourself. These are hydration reactions. And it is actually what you're doing. When your body loses water, your body is creating double bonds. When you're drinking water, that water then adds across the double bonds to give you something that is full of water and is more hydrated. If we add two bromines across the reaction, so now we're looking at this, and instead of a double bond, we're going to have a bromine and a bromine. And remember that this could be any halogen. We tend to use bromine a lot better because it's one of the better leaving groups, but it could be chlorine, it could be iodide. So these are halogens that are being added to the double bond. So the name is a halogenation. No, this is hydrohalogenation. This is just a halogenation. So the name is actually telling you what is actually happening. So one that's a little bit more difficult, what if you were adding a bromine and an OH across the double bond? So now we're going to look at this and we're going to say, okay, well, we have an OH on this side and we have a bromine on that side. What would we name this kind of reaction? And this is a halo, that's short for the halogen, hydrin, which is short for water. halohydrin reaction. And finally, if we add two OHs across, so we have an OH on either side of this reaction, what would we call that? Well, these are hydroxyl groups. So if we have two hydroxyl groups, that would be a dihydroxylation. So a reaction that's adding two OHs is known specifically as a dihydroxylation. We're also going to look at a reaction that does epoxidations. Now, epoxidation is something you're probably not familiar with. Maybe some of you have used epoxy resin before, and that has something to do with this functional group. Epoxidations are specifically a triangle that ends in an oxygen. So an epoxidation reaction will actually start from the double bond, and it will literally insert an oxygen where the double bond was located to create this triangle-like structure that has the oxygen at the very top of it. That's an epoxide, and we're going to be talking about epoxide reactions in this chapter as well. And finally, the last type of reaction that we're going to be looking at is a reaction in which you have a double bond or a triple bond, and you do a cleavage reaction. That reaction is going to break both bonds, the pi bond and the sigma bond, and it's going to separate it into two different compounds. Because that separation of those two different compounds is done with a cleavage reaction that includes oxygen, these reactions are known as oxidative cleavage. Oxidative cleavage reactions are going to end up with an oxygen, a doubly bonded oxygen on one side, and a doubly bonded oxygen on the other. And so you end up with two products instead of one, which is why it's called a cleavage reaction. So all of this kind of information is here just to tell us that by looking at the name of what it is that we're creating, we should be able to figure out what is going on just simply by the name. And if we look at what's being added to the substrate, we can also, therefore, are able to name it. It's going to be much easier for us to be able to know what's going on if we can use the correct terms to say, this is what's happening across that double bond. Now, something that comes to mind and happens very often in organic chemistry is that when we're adding two different things across the double bond, it turns out that they can add in two different ways. So if we were adding two hydrogens, and I'm specifically looking at my blue marker, and I said, okay, well, the double bond is going to go away, and it's going to add a hydrogen to this position and a hydrogen to this position. Since I cannot tell the difference between the hydrogens, it doesn't matter which hydrogen goes to which hydrogen to which carbon, it's going to be exactly the same. But if I have something that is different, so in this case I have a hydrogen of bromine, then I really have two possibilities, don't I? I have a possibility, and I'm going to change color so that you can see the difference, where the hydrogen might be added to the position that is more substituted, and the bromine is added to the position that is less substituted. Or I could also have the option where the bromine is added to the more substituted position, and the hydrogen is added to the less substituted position. These are my two options of what could possibly happen. So what does happen? And the answer is both of those things can happen, but it depends completely on the mechanism of the reaction. And remember that mechanism is how the electrons flow, how that reaction happens, how these molecules interact with each other. How do the electrons attack each other, and how does this actually work? So in order to be able to differentiate where something is going to go when you have two different things, and this is the same whether we have a hydrogen and bromine or a hydrogen and an OH, all of these are going to be known as the one that has the extra group, okay, so the OH or the bromine. When those two things are added to the more substituted position, this position right here, we call these kind of reactions Markovnikov reactions. Again, Russian organic chemist has his name. So these are known as Markovnikov reactions. We normally abbreviate it MARK just to make it small and for us to be able to remember it a little bit more. But if the thing that is being added to the more substituted position, we refer to that as a mark addition. So if my bromine ends up at this position, if my OH ends up at this position, it is a Markovnikov addition. On the other hand, if that which is being added, other than the hydrogen, is being added to the less substituted position, it is referred to as an anti-Markovnikov addition. Or we can just abbreviate it saying it is an anti-Mark reaction. Now, it would not be correct to say that if you're adding the same thing on both sides, like when you have hydrogen and hydrogen, or when you have bromine and bromine, or when you have OH and OH, if you're adding the same thing to both sides, then the reaction is neither Markovnikov nor anti-Markovnikov. It's just a plain and simple addition reaction. So there's a little bit of nomenclature here. There's a way of describing these reactions. We have reactions that are plain addition reactions. We have reactions that are addition reactions that follow Markovnikov's rule, or we have addition reactions that form anti-Markovnikov additions to a double bond or even a triple bond. So knowing the difference, whether a reaction is going to be Markovnikov or anti-Markovnikov, is going to be very important. And I can assure you that in order to determine whether a reaction is Markovnikov or anti-Markovnikov, it is directly related to the mechanism of the reaction. So at this point, many students want to just grab all of these addition reactions and want to memorize a list that says, okay, if I add these reagents, I'm going to add hydrogens to the double bond. If I add these reagents, it's going to add Markovnikov. If I add these reagents, it's going to add anti-Markovnikov. And they spend lots of times with lots of flashcards memorizing all of these reagents and what is the product that they're going to get. However, I will warn you that doing that might be an effective way to get some points on the exam. It's not going to be an effective way of understanding why things are happening. The people who want A's and high B's usually are the people who understand why a certain reaction is happening. And we're going to be looking at each one of these reactions, and we're going to be looking at why is one reaction going to have the bromine go to the more substituted position, whereas if I change the reagent slightly, I now am going to have a bromine that's going to add to the less substituted position. In each one of these cases, it's going to be explained by the mechanism that creates each one of these reactions. So addition reactions is what this whole chapter is about. How these addition reactions happen is through a specific mechanism. Certain reagents are going to give you certain products. Memorizing the reagents is the only way to get from point A to point B. There is some fluctuation with the reagents, and I might come back and make another video showing you what those different fluctuations might be that might show up on an exam or a final that are different than ones that are showing up in your videos. But for the most part, this is very cut and dry. There's no explanation. There's just an entire mechanism. And in each one of the videos, they are going to show you the mechanism of how those specific reagents are adding across a double bond. And they're going to explain whether those reagents are adding Markovnikov or anti-Markovnikov. Since it's very straightforward and everything is being done very specifically, these videos are coming from Khan Academy or Dr. Dave, or maybe even, there's another one that I like, the girl. I can't remember. But there are a couple different sources where I find all of these explanations are pretty straightforward. There's no theory behind it. There's nothing that I need to elaborate or explain. They do a very good job. So for the rest of Chapter 8, most of the videos are not going to be personally mine, but I will come in and make a video specifically about our class and what additional reagents, if any, you need to add to your repertoire of things that you need to know. So this introductory video for chapter 8, which deals with alkene chemistry, double bond chemistry, and then the next chapter is going to go to alkyne, and again, that's very similar. We're just going to go from a double bond to a triple bond, but we're going to end up adding all of these same things to the triple bond, just like we did the double bond. So it's very analogous. That's why chapter 9 is actually really short, because it just tells you, look, if it happened with a double bond, it's going to happen with a triple bond. This is how things change just a little bit when you have a triple bond instead of a double bond, but it's not that hard to apply everything that you learned for double bonds for triple bonds. And finally, the very last thing that we're going to see in this section are radical reactions. And radical reactions have an entire chapter. That's chapter 10 in your textbook. But if you notice from your reading chart, I don't actually ask you to read the entire chapter, nor am I making you responsible for everything that's in that chapter. I really just want to focus on a very few things. So there's it's a very condensed form of chapter 10 that we're going to be looking at, and that's why I'm able to do an exam that contains all 4 of those chapters, because really chapter 10 is just a tiny little smidgen that I want you to know, and I want you to know how to be able to add a halogen to something that doesn't have anything but carbons and hydrogens and alkane, and how radical reactions actually work, which are going to be quite important for you when you start studying cancer and other kinds of diseases like that, because these are all radical reactions that are going astray in our body. So I hope this gives you a pretty good overview of what we're going to be doing for the rest of this section and before the 3rd exam. And again, if you have any questions, please email me. And as I said, I might be adding more videos that explain things, but for the most part, I've already loaded up all the videos that are necessary for these 2 chapters, so that you can go ahead and focus on learning the reagents that you need to learn. I highly recommend that you go to class and talk to the TAs. The TAs will give you hints on what is important in these chapters and how you can best learn all of the material and what products you're going to get from them. So there is a little bit of memorizing, but hopefully it's not complete memorization. Hopefully you're actually understanding how it is happening, because understanding how it's happening allows you to really be able to reproduce the mechanisms and to be able to understand why that's happening, not just what the actual product might be. So again, I hope this helps, and email me if you have any additional questions.